Hello everybody, welcome to our mathematics channel 360 degree mathematics. In the last video we discussed the introduction of complex number, and in today's video we are going to discuss a part of analysis of complex number, that is a plus ib expression. A plus ib expression in complex number analysis. When a complex number is expressed, then the usual form becomes a plus ib. There exists a real part and an imaginary part in the whole expression. Now, by some problems, the expression can be established as follows. The question number 1: express I plus I square plus I cube plus I to the power 4 plus I to the power 5 in a plus ib form. Let the given quantity be z equals to I plus I square plus I cube plus I4 plus I5 equals to I plus I square means minus 1, we know already. I cube equals to I square into I4 equals to I square whole square, I5 equal to I square into I. For I square, where we get I square, then we put minus 1, that is I minus 1 into I minus 1 square and plus minus 1 into I, and a whole part is I minus 1 minus I plus 1 plus I. By cancellation we get equals to I, z equals to I. We can write I as 0 plus 1 I, and hence a equals to 0 and b equals to 1. Therefore, z equals to 0 plus 1i. This is the proper structure of a plus ib expression. Problem number 2: express 1 plus I by 2 minus 3i in a plus ib form. Let the given quantity be z equals to 1 plus I by 2 minus 3i, 1 plus I into 2 plus 3i by 2 minus 3i into 2 plus 3i. We multiply both numerator and denominator by 2 plus 3i, and it becomes 2 plus 2i plus 3i plus 3i square and 2 square minus 3i whole square. 2 plus 5i plus 3 into minus 1, 4 minus 9i square. That is 2 plus 5i minus 3 by 4 minus 9 into minus 1. That is minus 1 plus 5i by 4 plus 9, and it becomes minus 1 plus 5i by 13. This is minus 1 by 13 plus 5 by 13 I, and this is the expression of a plus ib, where a equals to minus 1 by 3 and b equals to 5 by 13. Now we focus on the third problem. Express 1 by 1 minus cos theta plus 2i sin theta in the form of a plus ib. Let z equals to 1 by 1 minus cos theta plus 2i sin theta. By separation we make bracket for 1 minus cos theta, and 2i sin theta will be separated part, that is imaginary part. Multiply both numerator and denominator by 1 minus cos theta minus 2i sin theta. We get in the numerator 1 minus cos theta minus 2i sin theta. In the denominator we follow a square minus b square structure, that is 1 minus cos theta whole square minus 2i sin theta whole square, and by simplification we get this 1 minus cos theta by minus I2 sin theta by 1 minus 2 cos theta cos square theta plus 4 sin square theta. This 4 sin square theta is sin square theta plus 3 sin square theta, and it becomes 1, and in the denominator we get 2 minus 2 cos theta plus 3 sin square theta. This denominator is I free denominator, and now we can express 1 minus cos theta by 2 minus 2 cos theta plus 3 sin square theta. This is full a part, and plus I minus 2 sin theta by 2 minus 2 cos theta 3 sin square theta, this is b part, and this is the expression of a plus ib, 1 minus cos theta by 2 minus 2 cos theta 3 sin square theta plus I, this part minus 2 sin theta by 2 minus 2 cos theta 3 sin square theta. This is the expression of a plus ib, where a equal to this and b equals to this. Now we focus the fourth problem. Find the, this is to some extent different problem, find the multiplicative inverse of 1 plus I. This multiplicative inverse means whenever we find z as a plus ib, then we have to find also 1 by z. This is multiplicative inverse. That quantity, let the quantity be z equal to 1 plus I. Now the multiplicative inverse is 1 by z, that is 1 by 1 plus I. And hence multiplication, here multiplication 1 minus I and 1 minus I in numerator and denominator, that becomes 1 minus I by 2, and it can be separated as 1 by 2 plus minus 1 by 2 I. This is also a plus ib expression. This expression is a plus ib, where a equals to half, b equals to minus half. Now we focus the number 5 problems. Express 2 minus root 2 minus 25 by 1 minus root minus 16. That is, numerator is 2 minus root minus 25, denominator is 1 minus root minus 16 in the form of a plus ib. Let the given quantity z equals to 2 minus root minus 25, 1 minus root minus 16. It is written as 2 minus in bracket 25 into minus 1, and in denominator root over 16 into minus 1, and it becomes 2 minus root 25 root minus 1, 1 minus root 16 root minus 1. That is 2 minus 5i by 1 minus 4i. Multiply both numerator and denominator by 1 plus 4i, we get this 1 plus 4i by 1 plus 4i, and 2 minus 5i plus 8i minus 20i square, 1 square minus 4i square. The denominator now becomes I free denominator, that is 1 minus 16 minus 1, 17, and in numerator we get 22 plus 3i. Now 22 by 17 is a part, that is a part, and 3 by 17 is b part, a plus ib. This is the expression of a plus ib, where a equals to 22 by 17 and b equals to 3 by 17. Now we focus the question number 6. The problem number 6 is to some extent different problem. Find the real value theta for which the expression 1 plus I cos theta by 1 minus 2i cos theta is a real number. Let the given quantity be z equals to 1 plus I cos theta by 1 minus 2i cos theta. Multiply both numerator and denominator by 1 plus 2i cos theta. We get by simplification 1 minus 2 cos square theta plus I 3 cos theta, and in denominator 1 minus 4 into minus 1 cos square theta. The denominator is I free denominator. Now we express 1 minus 2 cos square theta by 1 plus 4 cos square theta plus I 3 cos theta by 1 plus 4 cos square theta. This is the expression of a plus ib, where a equals to this, b equals to 3 cos theta by 1 plus 4 cos square theta. Since the whole expression becomes to be real, therefore the imaginary part will be vanished, and hence for real z cos theta must be 0. Hence cos theta equal to 0 implies cos theta equal to cos pi by 2, that is cos 90 degree. Hence for general solution theta equals to 2n pi plus minus pi by 2. Now we focus the last problem, question number 7. Find the quadrant in which conjugate of 1 plus 2i by 1 minus I lies. Conjugate means z bar. If the value is z, then the value is then the conjugate quantity must be z bar. To find the conjugate quantity, firstly we have to express the given quantity in the form of a plus ib, and then now let z equals to 1 plus 2i by 1 minus I, 1 plus 2i by 1 minus I, multiply both numerator and denominator by 1 plus I. We get by simplification minus 1 plus 3i by 2, that is minus 1 by 2 plus 3 by 2 I. this is the expression of a plus ib, where a equals to minus half, b equals to 3 by 2. This is z expression. Now we have to find out conjugate of z. Conjugate of z is z bar, and hence z bar equals to a minus ib, that is a equals to minus half minus I 3 by 2, that is now a equals to minus half and b equals to minus 3 by 2. Since both values are negative, therefore the point lies in third quadrant, and by the following figure we can establish this. First quadrant all positive, second quadrant x negative, y positive, third quadrant both x and y are negative, and here we place minus half, the point is p, minus half minus 3 by 2. Therefore this conjugate expression lies on third quadrant as p minus half minus 3 by 2 point. And this is all about today about the a plus ib expression. Please watch our video and wait for the next videos. Thank you all for watching this video.